All right, tonight what we're going to be doing is we're going to be translating between words into the chemical equations that have formulas and symbols. So I want you to follow along, and I want you to use these hints until you get really, really comfortable with it. First, I want you to box out any compounds. So anytime you see a name that's a compound, I want you to box it out. Anytime you see an individual element, I want you to underline it. Whenever you see the words and with, I want you to put a plus sign above it. Whenever you see the word form or produces, I want you to put an arrow above it. Okay? Now, once you've done all these little symbols, what I'm going to want you to do is think about if it's an element. If it's an element, you are going to have to remember only one thing, and that is Honkelgriffs. Some other teachers call it, let me do it in this color, Hoberfinkels. So it's HobrfIncl. And it depends on what their teacher said to basically how they learned it. And so what they learned, it's ingrained in their heads. And so now they teach it to their students that way. So if your teacher uses Honkelgriffs or Hoberfinkels or Hofbrinkels, they all mean the exact same thing. And what they are all the symbols that are special elements. Okay, so if you look at it, it's hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, fluorine in this guy. And when those are elements by themselves, what actually happens is that they do not exist as an individual. Instead, they are known as diatomic molecules. And what is a diatomic molecule? Well, let's break down the word. Di means two. Atomic means atom. Molecules means bonds. So what they are elements that need two atoms to form bonds in order to actually exist. So if I ever said the word oxygen, oxygen never exists as O. Instead, it always is going to be a diatomic molecule. So whenever I say oxygen by itself, it's going to be O2. Okay, you always need two oxygens. Or you're going to, if hydrogen was by itself, you would be H2. That's the only thing you ever need to think about with elements. You either write the symbol or you make it a diatomic and write 2 after it. That's it. If you boxed out something or a word or words in your chemical reactions for compounds, what I want you to typically think of is CCC. And CCC stands for compounds, means you have your charges and you're going to need to crisscross those charges. And this goes back to the naming unit. Typically in this class we will be dealing with ionic compounds, and ionic compounds are ions, and ions have charges, and these charges need to balance each other out between the positives and the negatives, so that's where the crisscrossing comes. If it is not an ionic compound, then you'll name it as the covalent way, or you'll use the acid naming way. But typically in this class, they will always be ionic, so therefore the CCC method works most of the time. All right, so let's just go straight out into it. When we're looking at sodium hydroxide plus magnesium sulfate, I see sodium hydroxide. I see sodium, but I know sodium hydroxide is actually a compound, so I am going to box it out. Plus, well, it's already given to me, so I'm just going to write a plus. Magnesium sulfate is a compound. Magnesium hydroxide is a compound. Sodium sulfate is a compound. I already see the arrows and the pluses because those are not words, so I'm just going to rewrite them. Now going back to my formulas on the other side, what I noticed is that sodium hydroxide is a compound, so I'm going to have to worry about my charges. So what is sodium's charge? Sodium's charge is Na with a +1. You're going to be looking at your periodic table and your polyatomic ions sheet to figure this one out. Hydroxide is that "ide" ending, but it has multiple syllables, more than 2 syllables, so you're going to actually find on your polyatomic ion sheet. And hydroxide's OH with a minus, so when you crisscross it, you get a formula of NaOH. So once again, sodium hydroxide, as we did in the naming unit, would be named as, or formula would be NaOH. I now see this plus sign right here, so I'm going to retranslate it down and make it a plus down here. Magnesium sulfate, so it is a compound, so I need to worry about charges. So CCC, compounds, charges, crisscross. Magnesium will have a +2 charge. Sulfate, an 8 ending is found on that ion sheet, so we got SO4 with a -2. charges will reduce to be 1 and 1, so you will end up with a formula of MgSO4. That arrow I'm going to just rewrite. Magnesium, a lot of times for the product side, all you have to do is look on the reactant side to see the charges. So I've already looked up magnesium. Magnesium has that +2 charge. Hydroxide is OH with a minus. So when I crisscross, I'm going to need to remember to use parentheses around my OH so that 2 distributes to both the O and the H. I'm going to now add my plus, and then sodium is Na with a plus, and sulfate was SO4 with a -2. So when I crisscross that, I'm going to get Na2SO4. Note, for every compound, I worried about the charges and then I crisscrossed them. Your final thing that you're going to need to do when writing out reactions is you are going to need to balance them. If you are good enough to just see it at this point and not need to write out the work, then I am absolutely fine with that. So I noticed that there's 2 NAs on the right side, so what I'm going to do is put a 2 in front of my 1 NaOH on the left. So now I'm going to see I have 2 OHs on the left, and now I have 2 OHs on the right, so now I am totally balanced. If you are not good enough at balancing yet, then you can still write them out and do your counts with your polyatomics. All right, now what we're going to try to do is the bottom one, and the bottom one is full out words, okay? So I'm going to look at hydrogen. I don't see any words after that, so I know that this is an element. So I'm going to underline that. Reacts with, so I saw that with sign, or that with word. So with means I'm going to put a plus sign. Oxygen. Oxygen, I don't see a word after it. That would make it a compound, so I'm going to underline it, meaning it is an element. To form. To form meant that we're going to draw an arrow, and water I know is a compound, so I'm going to box that out. All right, so now what I need to do is I need to think about my elements. What do I do with elements? Well, the only thing you have to worry about is it a Honkelbrith or Holberfinkel? Okay, and I notice that hydrogen is actually the leading letter of that, so I know that it is a part of those diatomic molecules. So when it is a diatomic molecule, what you just need to do is you write it as an H2. Okay, now I see reacts with, so I'm going to do a plus sign. Oxygen, so I write down O, but now the only thing I have to worry about with elements is whether it is a diatomic molecule or not. So I'm going to look for O in my Honkelbrith, and I see it right here. So now I know that it is going to have to be diatomic, so I'm going to put a 2. Remember, it is only for these 7 elements that you are going to need to worry about putting a 2 or not. Any other element, such as sodium, if I had Na, so I said sodium reacts with, I would just leave it as Na. I would not need to put a 2. It is only for these 7 that you're going to need to worry about putting a 2 because they exist as diatomic molecules. Now I see the word to form, back to the equation, so I'm going to draw an arrow. In water, we do expect you to know that it's H2O. Now I'm going to try to balance it, so I just put a 2 in front of the H2O, or the water, which now means I need to put a 2 in front of my hydrogen. And now, because I am balanced, I am good to go. All right, hopefully you understand writing chemical reactions. Remember, all we are doing is we are merging the balancing that we just learned with how we did naming from the previous units. So it's just a blend. There's no new stuff other than that Honkelbrith, so don't worry about it.